So now it comes to the question, what is fluid kinematics? What is fluid kinematics? So as I mentioned, it is study of behavior of the fluid motion. It is study of behavior of the fluid motion with the space, with space and the time variable, with space and the time variables, without considering the forces which are causing this particular fluid motion, Now, so according to the continuum, the local velocity, it is the local velocity of the small fluid particle or the element at a given instant time t, and it is a continuously function of, it is continuous and it is a function of space and time. So now it comes to the question, what exactly the space and time is? So space is nothing but the coordinate system you are taking it there. So whether you are going with a rectangular coordinate system, whether you are going with either spherical coordinate system, whether you are going with a cylindrical coordinate system. What are the aspects? So generally, why do we discuss about this fluid kinematics, and what are the aspects of the fluid? What is required for me to go with the fluid kinematics? So what exactly this is real phenomena is happening in this one. So in order to discuss about this also, we are broadly categorized under the three aspects, or this why kinematics is required for us. Why kinematics is required for us? So there are three aspects given in this one. So one, it is development of the methods, development of methods and techniques for describing and specifying the motion of fluids. That is one aspect. Or this is the one aspect, is development of methods and technique for describing or specifying the fluid motions. Then the other one is characterization of different types of fluids. That means you may utilize it for development of the methods in order to describe about the fluid motions, or you may characterize that particular types of the fluid motion associated deformation. So the deformation is nothing but with respect to the shear stress. So already we have seen in the previous sessions that what is the shear stresses, so that deformation related to any fluid element, so that characteristic type of fluid motion, so the characterization of the different types of motion of the fluid with respect to that. Then the third one is determination of the conditions for the kinematic possibility of the fluid motion. Now the question comes, yes sir, to read it here, that is very convenient and comfortably we can make it out. What exactly this development of methods and techniques and says that specifying the motion of the fluid. So what exactly these development methods and the techniques is, when the fluid is moving over the body, what are the methods available by experimental approach in order to study that particular fluid behavior. And the second one, when you are talking about the characterization of the different types of motion and associated deformation, so this is linked to your Newton's law. This is linked to the Newton's law, that is Newtonian and non-Newtonian fluids. How this particular fluid behaves when it is moving over the solid body, or how this particular fluid behaves when one point to another point when I'm transferring this particular fluid element. And the third one is the possibility of the determine the conditions and the possibility of this particular fluid motion to happen in which direction. So that is the third case we have it in this one, right? Some definitions relating to that particular aspect, aspects of the kinematics of the fluid. So first of all, let us start with this streamline definition. So now the question comes, what are these streamlines are? Are they real or imaginary, first, or where do they exist? Does the streamline exist in the atmosphere? Does the streamlines comes from anywhere which is inside the room, or someone is applying it? No. So actually, as far as the streamlines are concerned, initial flow is allowed to move. When the flow is allowed to move in the defined control volume or controlled space, right? When this fluid is moving inside the control volume or in the controlled space, when we draw a tangent at the particular point, it is defining the direction of travel of velocity of the particular fluid. It is defining the direction of travel of the particular fluid element. So here you can see on screen There is one cylinder image. Here on screen you can see one cylinder image where the flow lines are moving over that particular body. And if I draw, see, if I draw one tangent here at this point, if I draw a tangent at this point, so I can say that at that instant, so let me again animate this one, right? So you can see here in this one, at that instant, if I draw a line, so at that instant, if I draw a line, so my arrow is representing, or this blue arrow is representing the direction of travel of that particular fluid velocity, right? So simple to define the streamline is to the velocity vector, tangential to the velocity vector at any point or at every point in the flow at a given instant, and forms a powerful tool in understanding of fluid flows. Now the next question comes: why? What is the need for you to draw that arrow up there? What is the need for you to put the direction there? I'm interested to know about how to travel in the x direction, but later is it traveling only in the x direction or it got diverted from the x axis? So when I notice that, when I go with the close observations on this one, I have seen that after hitting the cylindrical body, the fluid has been changed. The fluid velocity has been changed with an angle. It has been diverted. So that resulted, I got it how? Yes, I have drawn the vector at that particular point. I have drawn one velocity vector at that particular point. So that velocity vector only we are calling a streamline is a line which is drawn one at an instant or the tangential to the velocity lines. So there you get your streamline to the velocity vector at a flow at a given instant or at any instant when you are drawing along that particular fluid line. It gives the direction of the fluid velocity travel. And it can be defined as, so when you are expressing it the mathematical way, when you are expressing that in the mathematical way in all the directions of the fluid, when you are expressing it in the mathematical way, so we can write it as so that is du by u, so that is in the x direction, is equal to dv by v is equal to dw by w. That is for only streamlines. This is for only streamlines. So along the streamlines, so if you have taken, so here if you see the dx, dy and dz, three axes when it is being considered, and when I have drawn one velocity vector on this one, so this velocity vector can be defined or can be taken as Vx, Vy, Vz. So when we are drawing, when it is said it is a streamline, so that means the velocity can be defined as du by u. So what exactly this du means? U2 minus u1 by u. So u is actual velocity traveling in the direction, and du represents the change in the velocity which has happened from the point where we have drawn to the instant of that particular one. So that means here they are considering it from this instant to this point. So that is traveling with the dx distance. What is the change in the velocity to the actual velocity of the fluid flow in that direction? So this is also similarly. So that means here one it is in the x direction, one it is in the y direction, another one is in the z direction. The flow lines are parallel to each other. The flow velocity vectors, when we are drawing to each other, so they are parallel to each other, right? So as if you see here in this case, the streamlines the velocity vectors which were parallel, and when they are moved at this particular instant, so they are no more parallel to this one. So they are meant again. So the intersection is possible in this zone, and complete flow is changing. The fluid lines are, it is circulating around this one. So this we can know by knowing the streamlines, by knowing the definition of the streamlines. So we can determine this, how this particular fluid flow is behaving, right? So why do they go for this particular type of analysis is, so you can see here. So here you can see, so the velocity vectors are continuously traced. The velocity vectors, so we just concentrate on the animation first one. So when you are concentrating on the velocity vector, you just see by summing up all the velocity vectors, I came to know that how exactly the fluid is moving there. So here the blue line, here the blue dot is showing you that how exactly the fluid. So on the bottom one of it, you can see that I have joined all the velocity vectors and I have just traced the path of it. So that we will see it later. But as of now, it is only the streamline we were interested in. As of now, we are only interested in the streamline. So this I will discuss about it later, right? And here in this one, you can see initially here if you see, let me focus on some zone. So here in this zone, although they looks to be not intersecting each other, but after a certain time the fluid lines have been completely changed its behavior, and here you can see they are completely moving in a zigzag manner, right? And they are no more the streamlines, so they are not no more the streamlines. So that means the streamlines are getting intersected each other. So that means when they are getting intersected each other, the my velocity vectors may not be easily traceable, or we cannot trace easily the velocity vector. So we can say that it is only the tangential component of the velocity vector which gives the velocity along that particular direction, okay. So let us quickly move on to the next one, then again we'll come back to this slide again, right? Now sometimes even we will be calling it as a stream tube. Even sometimes we will be calling it as even stream tube. What exactly the stream tube is? The imaginary lines, when you're drawing around any body, or when you're interested to define about a control volume, the imaginary line. So that means this doesn't really exist. So that means this is one velocity vector or one velocity line, this one streamline, three streamlines. So like this, up to my interest. So based upon my interest, what I have done is I have just made a frame. I've just made a frame of this particular stream tube, right? So the definition of the stream tube is that the definition of the stream tube, which are the imaginary lines placed around with some shape or placed with some shape, the stream tubes, they form a stream tube. So when we are arranging the streamlines in some when we are arranging the streamlines in some shape, so they form some tube like structure. That tube will call it as a stream tube. Now, so that the imaginary surfaces or imaginary shapes can be created by using this stream tube, and which would be very useful in analyzing the fluid flow. Just like your when the area is decreasing, when the area decreases, what happens to the velocity whether increasing or decreasing, that type of analysis we can carry out in this stream tubes. So that means this would be helpful when you are analyzing the fluid flows by assuming some shapes in that, arbitrary shapes. So let us see again one more example here. This one. So instantaneously, how the CFD forms this one. So what exactly the CFD is actually? So in computational fluid dynamics, so when you are drawing it numerically, the numerical one, so here you can see that in the numerical one, this is called as a stream tube. But in actual mathematical format, we don't see, because this is an imaginary one. So the streamlines, see, you can see that another shape we have. So this is similar to the stream tube which is developed here in this one. So that is similar to what is shown in this particular image. So that is also a stream tube. So now we are talking about all this. So at a particular time, or at an instance of t is equal to t1, at an instance of t is equal to t2, at an instance of t is equal to t3, t4, if I start joining all these lines, individually when I approach to the individual lines, so where you are at this particular time, so all tracing that, I got to know, yes, at this t4 instance this was moving in this direction, and this has the at time t4. Similarly for other points. So here what I have done, I have traced their path. So how they are moving, I have traced their path, right? So here I'm just tracing the path of this particular fluid. Similarly, consider that in your fluid also, if I put some particles in that one, named blue, green, red, and yellow, I'm just tracing that particular fluid flow, how it is moving at a different time instances. When you are tracing this particular one. So how to define a path line is, a path line is a line traced by a given particle. And this is generated by injecting a dye inside the particular fluid, or any by photography means, if you are putting a particles in that one. So that way also we can trace the path of the fluid, how the fluid is moving there, right? So that is about the path line. Path line is nothing but the trace of the given particle. Next about the streak line. Right? So we have the particular point that gives the velocity, and next one we have talked about the path line. So that means it is talking about the path of the particle which is at the different instances of the path of that particular path of that. So you can see even the car is a simple example for the path line. So how the car moved in this different time intervals. So I would now the streak lines. Just concentrate. If you are clear about the previous one, the streamline and the path line. So streak lines will be very easy, right? So here what I have done in order to concentrate the streamlines, concentrate on the fluid particles that has gone from the fixed station. So here you can see, so that has started from the fixed station. So that has started from the fixed station T naught. That started from the fixed station T naught, and again I left the particles at the T naught time. I left the particles at the T naught time, and I have traced the particles. I have traced these particles at the line at an instant of time t. Again, after time t only I have traced these particles. After time t, when I have traced these particles, and when I'm saying it is a streak line, so I have joined at this time instance after t, at the time instance of again t4 or t, at the time instance of t naught to the t4 point, or at the t2 point, at the t2 point, when I've joined all this one, I just want to see. So this complete fluid which has started from the T naught location is the same fluid, but I have traced with the different colors. So when I have traced with the different colors at this time of T2, I have seen that the yellow was moving very slow, red was a little bit faster than yellow, and green was a little bit faster than red, and blue was moving very fast compared to the yellow. So that when I trace this one, so that means actual behavior of the fluid I got it. So the best example, in order for you to visualize this particular streak lines is, or in order to see that whether it is a streak lines or not, is you put a honey on a paper, or a plate, and just and let that particular honey to allow it to move. So you can make some inclination on that one. So when you make that honey to move, only the top layers will get movement will be in the very faster, and the bottom layer will be sticked onto the surface. Slowly it will stick onto the surface. So that honey layer, when you are tracing it, so how the fluid velocity is moving means, so that is moving in the parabolic path. So here if it is moving in the parabolic, so that means initially the yellow color line is completely having a very slow velocity, and the blue is having a very high velocity. But as far as the streak line is concerned, just have joined that particular line, have joined those all the points at a time instant, of t. So when I've joined all this one, so now I got to know that yes, this is what actually the path of the fluid. So that means here, which the fluid which has started at the T naught is the same fluid. When I have traced at the particular after time t instant, I've seen that the velocity variation is somewhat like this. The velocity variation is going with this, right? So